Good morning to everyone. We have discussed the simple inheritance in Java. We have discussed the simple inheritance in Java, and then we have discussed in what order the constructors are executed in multi-level inheritance. Then we have explored the uses of super keyword. Can you recall what are the two uses of super keyword? Super of X. What is the first usage of super keyword? To call the superclass constructor. So in that stage, the super statement, it must be the first executable statement inside the subclass constructor. Then what is the second usage of super keyword? Super dot method. So whenever the method having same type signature in both super and subclasses, to call actually the superclass method inside a subclass method, we need to use super dot method name, superclass method name. Likewise, when the instance variable is hidden right inside the subclass, that stage to actually to point the superclass instance variable, we need to use the super dot instance variable, or we can use super dot method name. So the two possible usages of the super keyword are discussed. Next, let us explore a more on method overriding. Two methods are said to be overridden, right? Two methods are said to be overridden if and only if the type signatures of a super and subclass versions are the same. Type signature in the sense that the return type, then method name, then parameter list. This is the type signature. Return type, method name, parameter list. So when both the super and the subclasses can have the same type signature with respect to return type, method name, and the parameter list, then the version which is available in the subclass overrides the version available in the superclass. Superclass version is said to be overridden in the subclass. In case if they differ in the parameter list, right, in that stage, method overloading will be taken place. That means method overloading in case of an inheritance. This is possible. Suppose superclass method name is void compute, zero parameter. Subclass version is void compute int a, one parameter. That stage what will happen is method overloading is taken with respect to this subclass, because one version of subclass takes some parameter and another version of subclass is actually inherited from the superclass. The superclass version is not overridden in the subclass. That stage what will happen means method overloading is taken place. Have a look into this example. A class A, one method void compute is defined and another method void list is defined. Class A is acting as a superclass. Class B extends A. This is a subclass extended class from class A. Same compute is there, right? Here a compute is defined, void compute. So in that stage, what will happen means the compute version of A, this is said to be overridden. Because here void compute, class B extends A, so the entire methods of class A are actually available in class B. But in class B, type signature of the method compute is same. Return type, method name, parameter list. Return type void, method name is compute, parameter list is empty. So same type signature is there. In that stage, what will happen means this is actually not available in the class because void compute this version is this version overrides the version available in the superclass or this is overridden in the subclass. So calling the compute method using the object of class B, version B is going to be called. This version is going to be called. And have a look into write another method test, void test. Here int test index is there, right? So return type alone is insufficient to distinguish for method overloading, the rule that we have discussed earlier. But here method name is test, here method name is test. Parameter list 0 parameter, here 1 parameter. So these two methods are said to be overloaded. Void test, just imagine this highlighted version is once again available in the subclass. But here int test of index is there. So these two methods are said to be overloaded. Calling the test method using the object of B with one integer parameter invokes this version. Calling the test method using the object of B without any parameter is that invokes this version, void test. So in this stage, the test method is said to be overloaded with respect to inheritance. So testing that we are creating the object of B, B is equal to new B, object of B is created, then B dot compute, B dot compute, what will happen means inside class B is compute. This is the result. Java C inheritance 9 dot Java. Java inheritance 9. First line, right? What happens inside class B compute? Because calling B dot compute, this version is called, but this version is already available in the super class. That is overridden here. This version overrides the version available in the super class. So inside class B compute is displayed this. Then B dot test. B dot test means right what will happen means test right without passing any parameter. Here, so this version is taken from the superclass inside A's test. That is the second line of output. Then B dot test system dot out dot println B dot test of 10. So in that stage, right, what will happen means we are passing one integer value directly. So 10 test of 10, one integer parameter, one integer parameter version of test. This is actually taken from class B. So this overloaded version is called, and the returned value is say 25. 25 is printed in the calling statement. Understand or not? Method overriding plus method overloading. The basic restriction is two methods, right? That is in superclass and subclass versions. Type signature must be identical one. If the type signature is not identical in super and subclass versions, then super and subclass versions are said to be overloaded. So overloading is possible in case of an inheritance. Having any queries in this example? Okay, let us move on to the next one. Now we are going to see the late binding runtime polymorphism in Java. In C++, using virtual functions and a base class object pointer, when base class object pointer is pointing the address of a derived class object based on the virtual function concept, right? The version which is available in different classes are going to be executed. Here, dynamic method dispatch. Already we have discussed the key concept to achieve a runtime polymorphism is the superclass variable, reference variable can point a subclass object. So that stage, the overreturn method calls are actually resolved at runtime. Thereby, Java achieves a late binding concept. Dynamic method dispatch calls achieve the late binding concept, right? Different calls, dynamic method dispatch calls achieve runtime polymorphism concept. Simply write a consider the class A, one method print is defined, inside which right we have given the message inside class B. Then class B extends A, the method is overridden, the print is overridden. Here we have given the message inside B. Then class C, which has been extended from class A, right? And now what happens? Class A, class A to B. Then class C, right, which has been extended from class A. Here we have given the message inside C. Now inside the main method, if we create the corresponding local objects, right, A obj, B obj, C obj, then using these corresponding objects, you can call the methods the print. So A obj dot print calls the version available in class C. B obj dot print calls the version available in class B. Using C object, you can invoke the version available in class C, right? That is a normal rule. Now have a look into this reference variable. Arrow is a reference variable of superclass E. Now the reference variable arrow can point any of its subclass object. The subclasses of A are both B and C. B is one subclass and C is another subclass. So arrow is initially pointing its own object. This is possible. The superclass reference variable or a class reference variable can point its own object, right? That is normal rule. Arrow is equal to A obj. This stage, right, we are calling arrow dot print means since currently arrow, a reference variable of superclass A, is pointing its own object, arrow dot print calls the version available in class B. So this version is going to be called inside B. Second stage, arrow is equal to B obj. Now the reference variable of a superclass is pointing the object of a subclass. So in that stage, arrow dot print means what will happen means arrow dot print. Carefully look into right the version print. But print right this is overridden method. Now the overridden method calls are resolved at runtime. Now B obj sorry arf dot what one arf is equal to B obj arf dot print. This is same as B obj dot print. Now the version which is available in class B is going to be invoked. Inside B is displayed. Then arf is equal to C obj. The superclass reference variable is now pointing the version which is available in the third class, say C object. Arf dot print. This calls the version available in class C. As we discussed earlier, right? For example, if we are in different locations, for example, in bus, if I ask you to buy a ticket, you will be buying, right, the bus ticket. If we are in the station, if I ask you the same statement, for example, buy a ticket, right, you will be buying the station railway ticket. If you are in the theater, right, if I ask you to buy a ticket, right, you will be buying accordingly a ticket. So buy a ticket, right? Just write a single statement. Buy a ticket. Which is a simple statement. This is a query, right? This is one executable statement. Buy a ticket at different situations will respond, right? Will respond in a different way. Likewise, here, if you say write one executable statement like buy a ticket, right, at different situations, the corresponding versions of the situations are going to be called. So buy a ticket, right, it seems that arf dot print here arf dot print, arf dot print. After some milliseconds calling same arf dot print, this invokes the version available in class B. After some milliseconds, you are calling arf dot print. This calls the version available in class C. So it seems that only one executable statement, right, one executable statement calls the version which are available in different classes, and the method calls are completely resolved at runtime. That's what this is said to be a runtime polymorphism in Java. Having any queries in this Java C inheritance enter Java inheritance 10. So first inside A, inside B, inside C, corresponding to the normal object call. First object dot call, second object dot call method, third object dot call. Its own methods are called. Then aref dot print. First time it calls a version available in class C inside B. Same statement after some milliseconds. Aref.print calls the version available in B because a print is said to be overwritten method inside class B, right? And print, right, is actually the version of the object B. So class B version is called. Then after some milliseconds, aref.print this calls the version available in class C. So thereby Java achieves a runtime polymorphism concept. That means dynamic method calls are resolved right at a later time. That is, you can say late time. So this is to be late time polymorphism or runtime polymorphism. To implement that, you must have the implementation of inheritance method override. Having any queries?
Sir,
Yes.
sir, if we have
Yes, tell me.
sir, if we create an object of superclass, sir, and if we assign the same to the if we assign the subclass object, sir, then and if we want to invoke the subclass method, then how could we do that?
Okay, 1 minute. You already asked I think that query. Let us check it. Superclass object is AOBJ. AOBJ is equal to POBJ, right? Then
Yes,
call
sir.
AOBJ dot print. AOBJ dot print. Let us check this system. ABC, then B. Because A object is pointing B object. So AOBJ.print calls the version available in class B. Suppose AOBJ is equal to COBJ, calling AOBJ.print calls the version ABC, then BC, version available in class C. This is because in the last class itself, right, in square and rectangle class, right, we have illustrated that when the superclass object is assigned the corresponding subclass object, right? What is actually referred using the superclass object? That is the important question. When there is a same variable, right, which is available in both and super and subclasses, right? So with respect to that, only that instance variable or method is going to be called. In this example, we do not have any instance variables. Only method is there. So when the superclass object is pointing the subclass object, it can have the rights of only accessing the superclass method. That means here when the superclass method is overridden, that overridden version is pointed out. That's the thing. But using this object, say after this AOBJ is equal to BOBJ, assuming that one other method, suppose some F is there inside the class B, you cannot access using AOBJ or to call the method F because AOBJ cannot have the rights to access some other methods other than the overridden methods. Okay.
Thank you, sir.
Sir, is there anything like compile time polymorphism? This is runtime polymorphism, sir.
Yeah,
Is there anything
compile
like
time polymorphism. Yeah, 1 minute. A compile time polymorphism is a concept of constructor overloading and method overloading. there, right, the entire method called determination is made during the compile time itself. But here, why it is to be a runtime polymorphism, we just have the concept of, suppose class A, right, as some constructor is there, one argument constructor, two argument constructor. At the time of object creation, right, during the compile time itself, the right version to be called is determined. But in case of runtime polymorphism, which method, right, we are going to call, right? Because this is the statements are going to be executed in the sequential order. Here, ARF may point to B object. At runtime, right, ARF may point another object, COBJ. Here at runtime, right, ARF can point, right, to some other object. So only at runtime, that is at late time, the method call is resolved. That's what this is to be a late binding concept. This is
Sir,
one possibility. Yeah.
sir, what happens if we use bref is equals to say
Hello.
obj?
Bref is equal to COBJ.
Yes, sir.
It's not possible. I'll show you. Bref. And when the same statement you can assign. Bref is equal to COBJ. This results in a compile time error. Because incompatible types. C is one class, independent class. B is another class, independent class. There is no relationship between these two classes since B and C are completely independent. We cannot assign like this.
Yes, sir.
Yeah, what I have said. This is one possible way how Java achieves a runtime polymorphism, right? Another possible way of achieving runtime polymorphism in Java is with the help of abstract classes, right? We see right after this, after write one more example. Abstract classes. I would like to demonstrate right the runtime polymorphism with one example, right? For example, in C++ you may have studied what one? Abstract superclass. That is abstract base class because in C++ the concept is base classes. Simply abstract class. Can you recall that abstract class? A class that cannot be instantiated is said to be the abstract class. Okay, that simply
Yes,
acts
sir.
as a base class, right? So let us see right how to extend this example, right, to form the abstract base classes and how the abstract classes are going to achieve a runtime polymorphism. So before that, right, you try to see this example, class shape, right? Normal runtime polymorphism concept. Class shape, which defines two instance variables, say float x comma y. We need to extend this class shape into some new classes, say triangle, rectangle, parallelogram, and trapezoid. And then we need to compute the area of these two-dimensional objects using runtime polymorphism. So class shape, right here, this is not an abstract class. Later we do like to implement this as an abstract class. So as of now, right, let us apply the code reusability concept. So try to optimize the number of instance variables and methods as far as possible. So class shape, right, defining two instance variables x and y. Then because the class can be used as the superclass for some of the subclasses, better to initialize the instance variables through its constructor. Float x comma y, then shape constructor is defined. Then constructor with the two parameters x is equal to a and y is equal to b is defined. Then area, right, we have given one method, right, area, right, which is used to print the value of area. If possible, right, you can also define one variable area here, common variable. The variable can be utilized in some of its subclasses. But here I have given right normally one message area is right. This is a superclass sheet. From this, we need to extend some triangle, rectangle, parallelogram, trapezoid classes. In triangle, right, what we have to do means a triangle float A, float B. Assuming that a triangle requires right the two parameters, say base and height, to compute its area. Here you need not assign, right, the actual instance variables x is equal to a, y is equal to b. Since the superclass has already defined, right, its own constructor, simply pass the value super of a comma b, right? So when we construct an object of triangle class, pass the actual parameters which are received in the formal parameters a and b. Super of a comma b simply initializes the instance variables x and y of a triangle class. Then void area, right? Here void area, same method overriding is taken place. Simply I called, right, to print the message area is, so I called super dot area here. So area is message is displayed, then system dot out dot println a triangle plus area is directly computed here. Likewise, a rectangle which requires two parameters. So you need not initialize the actual superclass inherited variables x and y. Simply call the rectangle class constructor float a comma float b using a super statement. Then area is printed accordingly. Then parallelogram, say length into breadth similar to a rectangle, a super of a comma b. The superclass constructor is called to initialize the members of parallelogram. Then trapezoid, assuming that the trapezoid requires three parameters of h into diagonal 1 plus diagonal 2, right? Half h into, right, the base 1 plus base 2 length, right? So in that stage, right, what you have to do is you need a third parameter. Using inheritance, we are optimizing the number of variables. So h only mentioned here, say remaining, right, say a base 1 and a base 2 heights are actually taken from the superclass instance variables. So calling super of a comma b, first two parameters are used to initialize, say base 1 and base 2 length. The height is obtained, right, in a variable h. It receives the third parameter value h is equal to c. So as far as possible, right, we are trying to optimize the instance variables and the methods. Void area here, right, the area is, for example, 1 by 2 h into d1 plus d2, base 1 length plus base 2 length. Area is computed. Then inside here, shape s is equal to new shape. We do not want to initialize directly the instance variable of the shape, but try to create one reference variable of shape is and create the objects of the extended classes rectangle, triangle, parallelogram, trapezoid. Then assign the subclass object to the superclass reference variable sref is equal to r, then call sref dot area. This calls the version available in the rectangle. sref is equal to t, same statement sref dot area now invokes the version which is available in the triangle. sref dot p, right, sref dot area, sref is equal to p, sref dot area now calls the version available in the parallelogram class. Then finally it calls the version available in the trapezoid class. So only one executable statement calls the version available in different classes. So runtime polymorphism is achieved. Having any queries?
Sir, can a subclass reference variable initialize? Can we initialize it to a superclass object?
Subclass reference variable, subclass reference variable, say rectangle class. Okay, that can be.
It can be equated to superclass object. Can it be equated?
It's not possible. Superclass object, superclass, for example, S is a superclass object. Creating one rectangle instance. Rectangle, say R ref. S is equal to R ref. I think it results in a compile time error. Variable R ref might not have been initialized because even right s is s ref, right, or s or whichever is, even try to write right s ref also. is equal to R. Let us try reference variable to reference variable. Yeah, R might not have been initialized. So whichever you would like to assign to the left hand side object or a reference variable, the right hand side that must be a memory allocated one. So this results in the rectangle out of the is a reference variable. In the practical exercises, right, whenever you try to implement the polymorphism concepts, right, you try to take this example, computing the area of some two-dimensional objects, or computing the volume of two-dimensional objects, three-dimensional, sorry, computing the volume of three-dimensional objects using runtime polymorphism, without and with abstract classes. You try to do some practice on these exercises. So finally, right, we need to see what is an abstract class in Java. The previous example, we have defined one class shape. Even the class shape is used in some of its extended classes. We are not used the shape class object, right, to access something. It's possible actually, right, but we do not, but we didn't use. So in that stage, right, it is better to make, right, the super class as an abstract class, and we can concentrate only on the extended classes. So what is an abstraction? Abstraction will give you the overall idea. That means you need to declare method only. Method declaration only be provided in the super class. But whenever the subclass extends the concept of the superclass, that is a role of subclass to provide the complete implementation of the superclass methods. Then that stage, the superclass must be made as an abstract one using the keyword abstract. So what is an abstract? Abstract is a keyword in Java that is used to define one class as an abstract one. So whenever a class is declared using an abstract one, explicitly using the keyword, for example, abstract, then class name, the extended rule is the abstract class must have at least one abstract method. Abstract class must have at least one abstract method. This is a rule. So when a class is defined as an abstract one, what is the use? That is a question. Abstract class, right, cannot be used to create an object. That is not possible. Like C++ abstract classes. Only the extended classes can implement the complete details of the abstract class methods. So when the superclass would like to keep the information as abstract, that stage, superclass will not provide the complete implementation. Only the required implementations can be provided in the corresponding subclasses. So subclasses can fit its own implementation corresponding to the superclass abstract methods. So that stage, what will happen is superclass just have the abstract method definition, but the complete implementation of that definition is provided only inside the subclass. So the class abstract that we are declaring, say abstract class name, must have one abstract method. Abstract method takes this general form. Normally method declaration is preceded by a keyword abstract, that's all. Abstract, then return type. Following that, you need to specify method name, parameter list. Since this is an abstract method, right, should not be defined in the superclass or should not be defined in the abstract class. It must end with a semicolon. So that's what, right, previously we have said that all methods must be defined inside the class except abstract class. Abstract class, it seems that only method declaration is provided, but the complete implementation is left to the extended classes. Extended classes can define their own implementations corresponding to the abstract method. Another rule, if a class contains at least one abstract method, the reverse, right, it must be declared as an abstract one. Abstract classes are not instantiated. You cannot create objects for abstract classes. That is not allowed. because the class consists of one abstract method, right? Using that, you cannot define the objects. So object creation for abstract classes are not allowed. Another extended rule: suppose a class X is made an abstract one, assuming Y is the derived class, right? A subclass from class X. Suppose class X consists of 5 abstract methods. All of the 5 abstract methods must be redefined in the extended class Y. This is a rule. Since the class Y has been extended from the superclass X, and assuming that the superclass X consists of n abstract methods, all of the n abstract methods must be redefined in the extended class. In case if you fail to redefine at least one method out of n methods, that stage we are providing only the partial implementation of the abstract class. During that stage, the extended class that fails some of the abstract method definitions. So the extended class must be declared as abstract one. Extended class must also be declared as an abstract one in case of partial implementation of abstract methods provided in the subclass. Abstract class can have non-abstract methods. This is another rule. Abstract class means it must have at least one abstract method. Other than that, you can provide the complete implementation of some other methods, say non-abstract methods. The non-abstract methods are completely accessible in the corresponding inherited or extended classes, or even the extended classes, right, may also perform method overriding concept. These are the rules of having abstract keyword in Java.
Sir, sir, what is the use of abstract methods?
What is the use of abstract method? For example, a class, one class C1 is defining an abstract method. For example, void construction. So, assuming that you like to construct different objects, say, I mean, right, different, say, mathematical objects, circle, square, glass, the circle, rectangle, cuboid, something, right? So, that stage, if you provide the common functionalities, right, only the common functionalities in the superclass, and the extended classes can have its own implementations to how to construct the square, how to construct the rectangle, how to construct the circle. So different implementations are its own are required implementations can be provided in the corresponding subclasses. That stage, the thing is when you have multiple classes, right, or multiple scenarios, when the multiple scenarios can have certain common features can be figured out, and that can be made as the abstract superclass, so that the extended classes can fit their own implementations. Thereby, the main advantage is the code reusability. Only one time, right, you can define the code. That code can be reused again or redefined in the corresponding subclasses. That is the only usage. Further, abstract classes are also helpful in achieving runtime polymorphism. This is another possible way how Java achieves a runtime polymorphism using abstract classes. To try to consider the same example, shape class that we have discussed earlier, I made that as an abstract one. Previously, it was class shape having something. Now I revised that into an abstract class shape. So the class shape has been declared as an abstract one. It must have one abstract method. At least one abstract method is required. So float x comma y shape, right, same thing. I made this as an abstract method. Void area, abstract void area. We can have some other methods, right? A non-abstract methods, say computing the area of 2D object. Now in the extended classes, right, what we are doing is, what is the rule? Class and the class triangle extends shape because shape is an abstract superclass. This abstract method must be redefined. In case if you fail to redefine this abstract void area, that stage, this class should be taken as the partial implementation of the superclass, abstract superclass. Here, it must be declared as an abstract one, abstract class rectangle extends shape. Now, assuming that the method area is redefined here, when you redefine the abstract methods, that you should not use the abstract keyword. This is a redefinition, right? Say void area, abstract should not be used. It needs a redefinition. Void area, print, right? Print calling the non-abstract methods, right? That is possible. Then triangle area is completed. Likewise, class rectangle, parallelogram, and trapezoid, right? We have seen the same example. Only thing is, one method is made as an abstract one. The abstract superclass methods are properly implemented in the corresponding area computation. Then, inside the main method, creating an object of shape. Shape S1 is equal to new shape. This results in error because S1, this is not possible. This is an abstract superclass. You cannot create any instances. Then rectangle or T, right, say the objects are created. What is the use, right? You can create only a reference variable. You cannot create an object. You cannot allocate a memory. Even x and y. Having right the method print method, you can ask what is the use of print method? Can you access the print method using the shape class reference variable? Not possible. Shape class object? Not possible. What is the use? In case when multiple classes can have common features. That's what I said. For example, constructing some object. Some construction right requires some common features means try to figure out those common features and put those common features in a particular method. That method may be put it in the abstract superclass. The same code can be reused in the corresponding extended classes. That is advantage of a code reusability. So in our case, shape right cannot create an object. Only the reference variable is created. Say shape sref. Then sref can point any of its subclass object. Right? Provided that subclass must not be an abstract class. Hope you understand. Subclass must not be an abstract class. In case if a triangle is an abstract class, right? Of course, right, a triangle object cannot be created. So sref can point any of its subclass object and calling sref dot area, which is actually pointed by the reference variable sref. Corresponding class area version is going to be called. So this is another possible way Java achieves runtime polymorphism.
So,
Yes. Yes, tell me.
so can we write sref.print, sir? After assigning it to a subclass, sref is equals to r, and after that, can we write sref.print?
Not possible. Because sref is just a reference variable. I said right, print method right can only be used in the corresponding subclasses. Sref.print. I will say the file. Oh, in this case, sref is equal to tr, right? Sref dot print. Print right, what will be printed? Print according to the object of which one? Currently, sref is finding tr,
Then of
trapezoid object. Sref dot area. Sref dot print means sref is currently finding the object tr. So trapezoid versions print version is going to be called this one. So of course, a print is not a overridden one. A superclass version is called. But it seems that The sref is currently pointing the object to tr, but here sref dot print. Now what happens? This results in a compiled error because the variable sref is not initialized. Using superclass reference variable, you cannot point right any of its object or any of its members, instance variables or methods. Having any queries in runtime polymorphism?
Sir,
Yes.
can you explain how the abstract class is used in this program, sir, particular program?
Abstract class. Abstract class means a class which contains at least one abstract method. For example, here it says shape, which contains one abstract method void area. The meaning is, since the class is made as an abstract one, you cannot create an object for the abstract class. So entire features of abstract class cannot be used itself. Abstract class cannot access any of its features, even non-abstract methods or even abstract methods. Only thing is, the extended classes can have the right to access these things. Because when you find out the common features of multiple things, right, into a single one, you need not redefine, right, the same task in some of the extended classes, writing the same code. For example, here I mean computing the area of 2D object, right? If I want to make the statement, I need to put, right, where means in all these classes, computing area of 2D object, here computing area of 2D object. So I can find out one non-abstract method like this. This can be put it in the superclass. And another one, here I fixed right some instance variables x and y. So only one time memory allocation is enough, right? So this memory allocation is enough to find out the area computation for some other two-dimensional objects. So void area, this is taken as a common method, abstract method. Triangle can implement the area computation in its own way. Rectangle can implement its area computation in its own way. Likewise, some other classes can find its own implementation of the abstract methods. That is a usage. So at that stage, all of the extended classes must redefine this method void area. In case when partial implementation is done in the extended classes, the extended classes can also be made as an abstract one. Then the further usage of those extended abstract classes are serving as some abstract to superclass for some other classes. So whenever the abstract to superclasses, the abstract to subclasses are there, those abstract to subclasses can be served as the superclass for some other extended classes. That stage, the extended class must redefine all methods of abstract to subclasses. That is the so common features are identified that can be made as in the abstract to superclass. The extended classes can redefine its features in its own way so that one interface multiple aspects method of runtime polymorphism is achieved with the help of abstract classes. That is a usage. For running that code data, you will get the same result that we have done in the previous exam. Having any other queries?
Sir, if we, sir, if we will not
Yes,
initialize any overridden method, sir, we are declaring an abstract method in the abstract class, sir. After, if we are not overriding the abstract method in its subclass, then we need to make that subclass as also an abstract class, sir.
Not overriding. 1 minute, let me take the same code. Yeah, void area. Okay, you're correct. Void area, when it is not defined in the subclass, make it as an abstract class. Abstract class triangle. That's what I said. Abstract class triangle. What is the use? The abstract class triangle can be made as a superclass to some other subclasses. Suppose a triangle, right? assuming that a hexagon, right? Assuming that a hexagon is drawn, right, using some different triangles. So that says, right, a class hexagon, when it extends the triangle means all of the abstract methods of this triangle must be redefined in the class hexagon. Even when hexagon fails to redefine any one of triangle abstract class methods, then hexagon must be redefined the abstract class.
So we
That
need
is the
not
rule
mention
of
any abstract method in the class triangle, sir, again.
abstract. What on?
Again, we need not mention any abstract method in the triangle, no, sir. Suppose we are making a triangle class as an abstract class, sir, and we are not having any abstract methods in it. So no problem, no, sir, in that case.
No problem, right? You need not define. You need not additionally define any abstract method since you failed, right, to define right the superclass abstract method. Abstract class triangle that is required. But you can also define some other abstract methods, additional abstract methods.
Okay, sir. Thank you, sir.
Then finally, right, we need to discuss some keywords with respect to the inheritance, right? As we discussed earlier, right, final, right, what happens? To define some symbolic constants. Final, right, int x is equal to 100. The value of x cannot be modified during the code. Similar to, right, has defined constant, right, in C and C++. We cannot modify the value of a final variable. Second simple usage, method overriding. If a method is declared, right, using final in the superclass, final void compute in the subclass, trying to redefine void compute, trying to override void compute, that results in error because it reports in the superclass the method compute has been declared as final one. Final in the sense that there is a final version of void compute. That's all. Final version of void compute. You cannot perform overriding concept. Another important usage. Sometimes, right, if you want to protect a class from being accessed by some of the subclasses or some other classes, right, that is perfectly valid. You try to declare the class as final one, final class X. Then the thing is, you cannot implement the class final class, final say class by extends 6. This results in a compile time error. These are the three uses of final keyword. Defining symbolic constants to prevent from method overriding or to prevent from the inheritance of a class. Having any other queries? Do you have any other
Sir,
queries?
is overloading possible, sir?
Overloading, which one?
After declaring final void compute, can we overload the same final void?
Overloading possible. Final void compute in the sense that, good question, void compute is the final version, which means void compute with 0 parameter is a final version. You can overload in the subclass, say void compute int x. Having any other queries? I move on to the next topic, right? Having a few 10 minutes, right? I try to focus on what is a package, a default package. It seems, right, strange, right, in this example. I illustrate this example. Have we discussed the Fibonacci sequence completion
Yes, sir.
using iteration and recursion, right? Can you recall that code? 1 minute. Yeah, this is the code. The same code, I have split it into two classes, two classes or two Java files, right? Same code. Say classes 15. The same code. I have not done any modification. So Fibonacci. So using these two classes, right, we already have a file, I think classes 15.java, having the classes 15 and having the class Fibonacci. The thing is, it is not necessary for you to redefine or to define the main method and user defined classes in the same file and keeping the file name as right, same main method class name. That is not required. In case if you like to write, define the classes separately, that is possible in Java. For example, I have completely defined the Fibonacci class as a separate class. Class Fibonacci user-defined class is written in this file. Then main method is defined in another file. Class say classes 15, in which right I have called Fibonacci FOBJ is equal to new Fibonacci. Why I have to illustrate this one means you need to carefully see what is classes 15.java. Classes 15.java is a separate Java file which is stored in some folder. In this, there is no class called Fibonacci, but Fibonacci.java is a class. Sorry, Fibonacci.java is a file which is stored in the same folder, Fibonacci.java here. Understand or not? See how we are accessing Fibonacci FOBJ is equal to new Fibonacci in this class, within a class classes 15. That is possible because of default package concept. A packages are collection of classes, interfaces, right? Enumerations, something. Different features can be combined into a single one. That is a package. So in classes 15, right, we are trying to access the file at Fibonacci. So to run this file, what you have to do is you need to call same thing, normal classes 15.java, then run a file Java classes 15. Program will be running. What is the folder? Default package example 1 minute. I enter into that folder. Control C. CD Java. I try to show running the file. Say classes 15. Java classes 15. Enter and say to second Fibonacci number is right. So greater than 3. Say 4 greater than or equal to 3. A fourth Fibonacci number is right a printer. Since we need to provide it n greater than or equal to 3, I already said. Understand or not? Because of default package concept, the file Fibonacci is accessible here. Likewise, have a look into this one a few minutes. Already we have the file inheritance3.java. I have separated those files into two files. One into inheritance3.java, the complete main method, and another one here the classes rectangle and square are separated. The class square has been saved as square.java, and the class rectangle in inheritance3.java is separated, and the file has been saved as this one rectangle.java. In that stage, you can execute the main method, this one inheritance3. In inheritance3, have a look into how square and rectangle are accessible, because Java creates a default package without any name. No name is given to the default package. So within the same folder, the files are put so that you can access one class into Java's another class within the same folder. That is the logic of a default package. And another one, having these two or three classes, rectangle, square, and Fibonacci, I define another file, def package.java, say default package.java. In this class, right, see, the class is also defined in the same folder, default package example, in which we are accessing the classes, say Fibonacci, then square, rectangle. These are accessible because the classes Fibonacci, square, rectangle are all defined inside the same folder, say default underscore package underscore example. That's what the classes, what one? Fibonacci, say square, rectangle are all having the default access code public with respect to the same package. Just think of, right, the default package example folder with respect to this folder, right? You can say the classes or methods, instance variables. There we didn't define anything. For example, Fibonacci. Sorry, in Fibonacci.java, we didn't define the class is public class Fibonacci. By default, Fibonacci is public with respect to the same package. So here in default package, right? Here we can access the corresponding classes. Java package. Enter in say 5. Fibonacci number, fifth Fibonacci number is assigned. Then area computation for square and rectangular rectangle. So package is nothing but a collection of classes and interfaces. Different collection of classes and interfaces are defined into a package. So before going to see how to create a user-defined package, I am illustrated the default package. So whatever the classes that you are defined inside this folder, say default package underscore example, you can access the files, access the classes, right, in the same package main method file. Here main method is defined in say default package, so this is possible. Not only in main method, in case if you want to access the inheritance, for example, class square is defined in square.java. Hope you understand. In rectangle class, okay, sorry, this is rectangle class. In rectangle class, right, we defined class rectangle extends square. What is square? Square is a class which is defined as square.java within the same folder. So that square class is accessible inside the class rectangle.java. Why means square.java, rectangle.java, all are defined in the same folder. But in case if square.java is not defined right within this folder, then you cannot extend square inside the class rectangle. This is the logic of a default package. Having any queries, so in the next session I will focus on how to create a user-defined package and how the package concept is imported. Once the package is defined, how can we import the package into the required number of the classes? That is the focus. If you have any queries, you can ask.
Sir, if the class file is inside the package and if the Java file is outside the package, means we can access that class file from our Java program, no, sir. It does not need the Java file, no, sir. If the class file is only present, means we can access, no, sir.
Which one are you doing? I do not get you. Are you pointing the user-defined package or a default package?
Our user-defined package.
User-defined package, right? We explore in the next class. For example, in the user-defined package, assuming that this is the folder. For example, a packages is the folder. So inside this, for example, I have defined some files. So these files, right, can be taken as a package. We can define the method. The method is going to access the contents of this average package outside the scope of the folder. For example, here compute average.java. Compute average.java can access the features of average package by importing the statement import average.store. So normal practice is try to define a folder in which store the separate classes. File1.java, class1.java, class2.java, class in.java. Coming out of that folder, try to import that entire package, import package name.star. Then use or access the corresponding classes in the required target file. Next class, right,
Yes,
I
sir.
will
Okay,
show
sir.
you the
Okay, sir.
demonstration of the packages. Hope you will understand later.
Sir, can the user-defined packages have main function inside them, sir? Will it show an error if there is main function?
Yeah, right. The different right users, right, that is users point of view. I tell you, in case usually, right, I prefer not to define the main method inside the user defined package. That's what I simply said. Here, user defined classes can be separately defined. Class1.java, class2.java, class3.java. In which, right, there is no need to write a main method. There is no usage. Only the classes are packed as a package. Whenever we need a class, right, that class can be accessible using the package, import package name dot star. But sometimes, right, the package class may also have a main method, no problem. That stage, right, the accessing will be somewhat with respect to the rules oriented one. I export it in the next class. In case what will happen to the main, if the main method is present inside the package, and what will happen if the main method is not present inside the package. Usually I prefer not to have, right, main method inside the package. In a main method, right, in which file we would like to access the package contents. In that we can use the import statement, and we can access the required number of classes from the package itself. Having any other queries?
Sir,
Yes.
sir, if we have a super class and a subclass, and if we sir, if we extend the superclass methods into a subclass and then create objects for both superclass and subclass inside the main method, then is memory allocated for same method twice, sir? I mean for both objects A and B. If B is
Yes,
extended from A,
yeah, memory is allocated for individual objects.
so for B object, memory is allocated for same method, and as well as for A object, we have memory for method, sir.
Sure, yes. Because for example, car is a class. You can create one object, right? C1, C2. For the same class, if you create two objects, C1 and C2, C1, for example, the tire type, C1 dot tire type is different from C2 dot tire type, because each object can have its own property, identity property. For the same class, separate memory allocation is possible. C1 dot tire type, assuming that tire type is one instance variable. C2 dot tire type occupies separate memory space. So likewise, when car has been extended into some other class, say X, and right, having some instance variable of object of car class object and object of X class, sure, different memory allocations are done.
Okay, sir. Thank you.
Okay, thank you very much. In the next session, we will focus on creation of user-defined packages and how to import the user-defined packages in the target Java application.